Hello and welcome to the Superposition Guys podcast. My name is Yuval, and today I'm sitting on the other side of the microphone. Jack Krupansky is guest hosting this episode and is interviewing me. I share my journey into quantum, discuss the recent Google investment, QuEra's roadmap, the importance of government support, and the potential for a quantum winter. Jack and I also talk about the evolution of quantum computing as part of a broader HPC ecosystem, expectations for production scale deployment, challenges such as talent acquisition, and much more. We hope you enjoy this episode.
Okay. Hi, this is Jack Krupansky interviewing Yuval Boger. Yuval, who are you and what do you do?
So my name is Yuval Boger. I'm Chief Commercial Officer of QuEra. QuEra makes quantum computers using neutral atom technology. At QuEra, we believe that neutral atoms is the best way to get to where we all want to, large-scale, fault-tolerant quantum computers. And we know that QuEra is both the scientific and commercial leaders in neutral atoms. And my job as Chief Commercial Officer is to help customers make progress in their quantum journeys.
Okay, great. One question that came up in my head was that how did you get started in all this? What was not what was the moment you first heard about quantum computing, but when was your light bulb moment when you said, aha, this is something I really need to pay attention to?
Throughout my career, I was always attracted to leading-edge technologies. For instance, I ran for many years one of the virtual reality pioneers. We made super high-end virtual reality goggles. I then worked at a wireless power company that can charge your phone over the air safely. And so quantum, once I heard about a quantum opportunity, at that time it was in my previous company, Classic, it felt like a natural thing. I have a master's in physics, amongst my other sins. So that sort of combined my love of physics and my passion of sales and marketing.
Okay, great. And at that same moment, or was it a later moment that you decided that not just that it was interesting, but that you needed to actually, it was for you to get involved in, not just to watch, but to be a participant?
Yeah, I mean, it's always these new technologies. I mean, one sort of unserious test that I take to figure out if the market is right for me is look at the Twitter handles. When I was doing VR, I was VR guy. And when I was doing wireless charging, I was charge guy. And then when I realized that qubit guy was available, that's where I figured that quantum was sufficiently early stage so that would be an industry that would be a good fit for me.
Okay, so just to recap there, it wasn't so much that quantum was ready, but that it was early. If it was ready, then it would probably be too late for you.
Yes, I spent some time running a cybersecurity company. And in cybersecurity, it felt like if you don't have 20 years of experience, then you're nothing. And so I never liked that feeling. So I was always attracted to emerging industries. So yes, quantum was early or is early. And that's one of the things that I like about it.
Great. Let's see. Let me get my question list. Sorry. Maybe you could just highlight some of the high points of your the quantum parts of your career. You know, things that you were most satisfying, and and things that maybe were boring, but were were necessary, versus things that were exciting but not necessarily didn't have necessarily a financial value in the immediate, but it made a difference for feeling like you're getting somewhere in quantum.
I think there are many moments of both types. I mean, we do a lot of different things every day. Some are more mundane, blocking and tackling, and some are more exciting. I think as a commercial leader, the sales part is always exciting. When a customer agrees to sign a deal, when we won the award for the UK National Quantum Program, when we closed the computer sale to Japan for AIST, That was a fantastic moment. Just a week ago, although I did not lead that effort, when Google decided to invest in QuEra, that was very gratifying. But then many other points. One of the things I do enjoy about this market is as you know, and as we are doing right now, I run a podcast. You used to be the qubit guy when I was at Classic, and now superposition guy when I'm at QuEra. And I get to meet all these fascinating people and ask them questions that I would be personally interested to learn the answers to, hoping that that's a representative of what my audience would like to. And so it's never boring in quantum. It's never boring to try to write a new piece of software or to look at a new computer. We had a video posted on the NASDAQ Tower in Times Square when Harvard and QuEra published what I think is a landmark error correction paper. That was a lot of fun. We had a survey a few months ago where we gave out these 2,000 part Lego models of quantum computers. Well, a lot of work went into designing that and preparing that and then sending it out. And both the response for the offer as well as the survey results were truly interesting. So I'm fortunate to have many high moments in my work at QuEra.
Okay, great. Now you did mention Google, so let me I had a question about that. Could you just briefly summarize what the Google deal was about? I mean, I read your press release and saw a tweet from Google, but I didn't see a press release from Google. So I'm not sure what Google thinks they're getting out of it. And, basically the simple question is, what does QuEra think they're getting out of this other than just the money? Because it's a strategic investment. That means there should be something more than finance involved.
So we're certainly getting the money, and we're also doing some collaborative technical work with Google. Even though Google is using superconducting qubits and we use neutral atoms, there are certainly areas of mutual interest, whether error correction or others. We also value the recognition. I mean, Google could have invested in many other companies, yet they chose neutral atoms and they chose QuEra. I can't speak to their motivation. I don't speak on behalf of Google, but we're very gratified both by the actual investment and what it signals the market.
Okay. Do you have any kind of a time frame for when you might expect to see some results come from the deal?
Now that we have the cash, you can start seeing us hiring even more people, buying even more equipment, thinking about expanding our offices so we can build more systems and of course, house the people that we hire. How soon the technical output will be, that is still to be determined.
Okay, great. Let's see, switching gears a little bit, or going back a little bit, I should say. Did you have any mentors when you're in your career, and either before quantum or in quantum at any stage, or were you more self-directed and didn't need a mentor?
I was fortunate to have many mentors, and one conversation that truly changed my professional trajectory was when I finished my master's. So I did a master's in physics. It was in fiber optic sensor arrays. It was in Tel Aviv University under the supervision of Professor Moshe Tur. So I did the thesis and defended it, and everything was great. And then I spoke with Professor Tur about what's next. And he said, Yuval, if you want to come and do a PhD and continue to a PhD with me, I'd welcome you with open arms. We have all these amazing problems we could work on. But between you and me, you should go do something else. A PhD may not be the right thing for you. And so in retrospect, that was one of the defining moments of my professional career. Advice from a professor who says, yeah, come do a PhD with me if you want, but go do something else.
Okay. That reminds me actually of another one of my question of kind of looking back at your career, are there any moments where if you had done things a little bit differently, it would have changed everything for you, hopefully for the better. But are there any regrets as to, do you regret not getting the PhD? If you had gotten it, would it have mattered? Or are there other moments like that?
I don't regret not getting the PhD. I know that my mother would have been proud if I got it, but now two of my sons, or my two sons, are pursuing a PhD, so maybe we'll make it up this way. I certainly have regrets on many things that I did or did not do during my career. I think they usually deal with people. Could I have behaved better? Could I have been more gracious? Could I have counted to 50 before I respond? And I hope that now that I'm in my 50s, I've mellowed more in some things that maybe I would have done more instinctively in my 30s. I can do better these days.
Okay, great. I hate to have to ask this question, but it seems like a pro forma. But were there any particular low points or extreme challenges in your career that either you had to slowly recover from, or that were learning opportunities? Put it that way, politely.
So, although I didn't plan it this way, I was always the startup guy. I ran software companies, virtual reality, cybersecurity. I was CEO of an ag tech company for some time. And in startups, they say either you succeed or you learn a lot, right? So sometimes we succeeded. One company I was part of went public on NASDAQ, and that was a great moment. And other times I've learned a lot. So I think the hardest moments were probably when you go to people and say, you know what, we're not going to continue. We didn't make it. We're going to have to shut down this company. I know you're all great people. You're going to find a job tomorrow morning. But as CEO, I failed you. I wish I would have done better. So these were always the learning opportunities. For me, it's always easier to learn from the failures than to learn from the successes.
Okay. And maybe that topic actually brings up an item from the news. Do you have any brief thoughts about a reaction to the demise of Zapata?
I know that there are a lot of good people that worked in Zapata, and hopefully some of them will come and work for QuEra. But this is the nature of an industry. Some companies succeed and some companies don't succeed as much, and it's just life. I know they made a lot of contribution to the field. I'm sorry that they had to shut down, and I hope all the people will recover and find even more exciting jobs.
And hopefully it'll be a learning opportunity rather than an absolute failure. Okay. Now that also brings up the question of, well, is this just a one-time thing here with Zapata, or is it a hint of things to come? So I'll just ask you your general thoughts on the topic we've talked about in the past of the possibility of a quantum winter. Is Zapata mean there's a quantum winter coming, or is it just, like I said, maybe a one shot? And how do you feel about, in general, whether the quantum winter might occur in the next 2 or 3 years? And maybe what technical milestones or business milestones would keep a quantum winter from happening, and what milestones, if we don't hit them, let's say next year, might bring about a quantum winter?
I'm personally not concerned about a quantum winter. I see the size of investments that are made both by investors and by governments. We see the progress that's been made in the type of computers, size of computers, error correction, algorithms, and so on. I think that most insiders would tell you that the industry is moving faster than they thought instead of slower. At some point in the past, there was some concern whether AI is going to take away funding from quantum computers, but that did not prove out to be the case, at least not in the long run. First, some, of course, now say, oh, we do quantum and AI. But then I think companies realize that this is two different horizons, that you could do something very useful with quantum with AI in 6 to 12 months. And in quantum, you're looking at a longer horizon, a larger time scale. So as long as the industry keeps innovating, as long as we keep thinking about how can we deliver value to customers sooner, then I think we'll be in good shape. And I was talking about that Harvard QuEra and also MIT and UMD and NIST paper from December of 23. One of the things that happened after that paper is that customers came to us, to me, and said, look, we originally thought that useful quantum was maybe 5 years away. But based on this paper, we have shrunk our estimate. We now think it's 2 or 3 years away. And that caused these customers to engage with us more in a deeper way to start truly preparing for useful quantum computers. So just to get back to the beginning, no, I'm not concerned at all about a quantum winter at this point.
Okay, and since we talked about some of these, like you mentioned the paper, how would say, maybe briefly, if you could summarize kind of where you are relative to at QuEra, to your roadmap that you had published in terms of this year and next year, things on track, and maybe just recap what these customers who were thrilled by that paper, what they can look forward to, let's say, in the next 6 to 9 months.
Well, I'm sure we will publish an update to our roadmap in a few months, but unfortunately, I'm not going to do it here and now. Customers are interested in larger computers and certainly are interested in error correction and logical qubits. And so there are many steps that have to happen for that. And with each generation that we promised and with each generation that some of the other companies in the field promised, it gets better and better. One thing I do want to note is that people sometimes come and ask, well, the Harvard QuEra paper showcased 48 logical qubits in December 23. Does that mean I can run 48 logical qubits today? And the answer is that there's a difference between a university experiment and a commercial system. Our existing system, 256 qubit Aquila machine, available for 2 years now on Amazon Bracket, is available for public use for over 100 hours a week. That also started several years before as a science experiment that only worked on Tuesdays between 10:07 and 10:09 after 3 days of calibration. So the scientific paper is phenomenal, and now we're doing a lot of the work to turn this or something like this into a stable, reliable commercial grade system.
Okay, let me drill down a little bit. So the roadmap that you have published was saying that for 2024, we're going to have 10 logical qubits. Is that still kind of roughly on track?
We are conducting experiments at QuEra with running algorithms on logical qubits, and soon enough, I hope that we'll be able to share some of these.
Okay. And if I remember right, the roadmap was that, and then for the next year, for 2025, you would hit 100 logical qubits. Was that right?
I think the roadmap was actually showing 2026.
Okay, 2 years. Okay, 2 years. So the question I actually wanted to ask was, but as you know from discussions with me, I'm kind of a fanatic about 48 qubits. If you have 48 really good qubits with great connectivity, you should be able to start doing some algorithms. So the question is, if we go from 10 to 100, but that takes 2 years, is it possible we could have something like 48 in the middle there somewhere? Or is it just going to be a 2-year desert?
So the roadmap that we published in early 24 spoke about 10, I think 30, and then 100. So there was actually an interim step between 10 and 100. Sometimes people ask, well, why this number and not that number? And of course, even to your question, you said you want to see 48 really good qubits. Well, what does really good mean, right? The ratio between physical and logical qubits depends on many things, including the encoding and the code distance and how resilient you want that code to be. So even with a system that has, say, 1,000 qubits, you could have different number of logical qubits depending on the level of encoding. But Yes, I agree with you that sometimes between 30 logical qubits and 100 logical qubits, this has become really interesting in terms of that you're passing the simulation threshold of classical computers, and maybe then you could do some truly fascinating things with quantum computers.
Okay. Let me just jump to some other random questions here. Um, how is the talent pool for quantum these days? Is it getting any easier or harder to find qualified or at least trainable candidates, or is it about the same? And how big a risk is it for, if you have a roadmap, is your roadmap going to be at risk because of talent pool issues, or you know, how confident are you about talent pool?
We see a number of things that are working in our favor. One thing is that many universities have started up quantum-specific programs, so to train people to more about quantum. The other thing is as we increase the visibility of QuEra. So, for instance, the Google investment certainly helps make QuEra attractive in the eyes of candidates. Well, if Google backing you, they must know something that uh, why they do it, and therefore this is an interesting place. The third thing is that you don't need just AMO physicist, atomic molecular optical physicist. Um, as we start building these systems, manufacturing more of them, servicing them, writing cloud software or algorithms for them, you need additional disciplines beyond just what you need for the core of the system. So the potential talent pool becomes bigger and bigger as the company um, develops. And not to mention sales and marketing people, social media, product managers, business developers, finance, HR, and so on.
Okay. Um, Getting back to investment, because you did mention government, and so my question here is, um, does government need to take a stronger role with like heavy duty industrial policy and a lot more funding, or have we crossed some threshold where we don't need government as much anymore, and that the private sector can take on more of the burden? Um, do we have the mix about right, or would you like to see more government involvement, or what?
I'm from the government and I'm here to help, right? That's the scariest sentence. No, but the government is truly helping in multiple ways. By the way, just yesterday there was a ceremony right near QuEra where the state of Massachusetts um, uh, unveiled an investment in building a quantum center. Sometimes we call it the Quantum Center of Mass, jokingly, and it includes funding to build a computer from QuEra that will be housed in that center. So not just federal governments, but also state governments are making such effort. I think that from my perspective, I see government as helping in many ways, but with two extremes of the spectrum. On one hand, financing and making it possible to perform high-risk projects where the commercial viability is not immediately apparent, where it's not necessarily going to be something truly useful to a business in 6 or 12 months, but serves a longer time frame. On the other extreme, and I think this was the case with the semiconductors, where the government can potentially guarantee some level of a market for these products. So yes, we want to buy X hours of quantum computing time and we want this kind of performance. And if you can do it, then great. So we, as the government, are going to guarantee some level of performance. Of course, the government has other roles. The government can encourage workforce development to make it easier to start quantum companies. Then there is the international side. What could the government do to make the world a level playing field, so it is easy for U.S. companies to sell overseas, so to remove protectionism. We basically believe in fairness, right? So if, say, it's difficult for US companies to sell into Europe, then it should be difficult for European companies to sell into the US. Or, even better, let's make it equally easy for everyone to sell the best type of quantum computers and let the customers choose, not necessarily the government, choose which vendor is best.
Okay. And you mentioned Europe, and we have this specter of export controls looming, and questions of quantum sovereignty and whatever. From your personal experience at QuEra, because you worry about Europe too, right? And you have a relationship with Israel and that kind of background. Is the international problematic at all, or is it more of an opportunity than a problem? And in terms of how you plan and think about strategy.
It's certainly more of an opportunity than a problem, and we're really delighted that we are able to deliver a system to the UK, to Japan, and hopefully to other countries as well. So we're very, very glad that we're able to do that. Of course, the picture is not uniform. So in some countries it is easier to do business with, in some countries it is a little bit more difficult. One of the really nice things that we liked about the UK National Quantum Program is that we thought that they found a good balance between building and protecting local industry while encouraging innovation from the outside. And in that particular project that we won, the requirement was that at least 50% of the innovation happen in the UK. But it's 50, not 100%. So it's okay to have 49% of the innovation happen in Boston or someplace else, as long as there is a strong UK partner or set of partners that can continue to do that. So I think they were able to find a really nice middle ground there, and we would encourage other countries to do the same.
Okay. Another government-related question. Some have suggested the need for a Apollo-style program for quantum computing to kind of get a critical mass, or what I would refer also to like a Manhattan Project, like we had with the atomic bomb. Does that make any sense to you? And if so, does the timing matter, or can it happen at any time? Should we do it now, or do you think it would be needed at all?
I mean, there are some aspects that, of course, would be very appealing, right? If the government decided to invest more money towards a goal of a quantum computer that does something, that would be fantastic. Whether this program needs to be centralized, like the Manhattan Project, well, that depends on who Oppenheimer is in this particular context, right? So yes, I think countries that invest in quantum are doing it for a very good reason. But I don't know if it should be completely centralized or just provide the opportunity for a more distributed approach.
Okay. Well, how about the national labs? Because they're already doing a lot of quantum work, and you have NIST as well. They did a lot of quantum work. Are you working closely with the national labs? So is that maybe good enough that you don't need an Apollo? If you didn't have the national labs doing their current role, then you might want an Apollo program. But since you have the national labs, are they a good enough kind of incentive to kind of keep the ball rolling in a lot of the more esoteric research areas that may not have immediate commercial requirements?
We are doing work with national labs, and we're very happy about it. Just a couple of months ago, NERSC, which is part of the Lawrence Berkeley Lab, published that they renewed their contract with QuEra, and that yielded several fantastic scientific results. In fact, they opened an award program for researchers to apply to use QuEra machine time to get additional results. So sounds like NERSC was very happy with the program, as were we. And we're also doing work with additional national labs. So yes, they play an important role in our progress.
Okay. On a different angle here. Do you feel that any of the existing quantum computing startups, particularly venture funded, are ever going to become the size of, say, a Microsoft or Intel or Google or IBM? Or are they all destined to either die off like Zapata or be acquired by Microsoft, Intel, Google, or IBM?
I think there will be some of each. Some companies will fail, some companies will merge, and some companies will survive standalone. Part of it is, of course, depending on the desire of the CEO and management team. Sometimes it's external considerations. Oh, I'm out of funding. I need to do something. And of course, companies are there to serve the shareholders and to provide returns for the shareholders. So sometimes there are opportunities that simply cannot be turned down.
So in other words, stay tuned. We'll have to see. There was one company that didn't show up on that list that I just gave you, and I wrote it as a separate question is, if you look at AI in particular, NVIDIA is like the big dog. I mean, you may be Microsoft, Intel, Google, or IBM, but NVIDIA is like all of them put together for AI. But NVIDIA has also expressed some interest and has some offerings in the quantum area. So I'm wondering, do you do any work with NVIDIA? And how do you see that NVIDIA, what role they may be playing in terms of just a secondary player, or will they be one of the primary players in quantum?
When we look at where customers want to deploy quantum computers, it's typically in data centers that already have significant NVIDIA deployment. So a lot of the HPC centers are looking at quantum as the next GPU, not so much replacing the GPU, but yet another coprocessor that can, just like the GPU can do things that the CPU cannot, will the QPU be able to do things that the GPU cannot? And if you get into a data center, then NVIDIA is of course very prevalent there. And so we work very closely with them. For instance, in the deal that I mentioned to deliver a computer to the National Institute of Standards in Japan called AIST, that computer is going to be installed right next to a classical supercomputer that's focused on quantum. That classical supercomputer can perform both hybrid quantum classical algorithms together with our quantum computer, as well as be a very powerful machine to simulate quantum circuits before you run them on the actual machine. NVIDIA has definitely put a lot of effort in simulation, in CUDA quantum, and in others. And so I think they play a critically important role. What will they do in the future? You'll have to ask them.
Okay. I guess I'm getting down to my last kind of few questions here. I have lots of questions actually, but a few that I definitely want to get in. One is a production scale deployment of quantum computers, or practical quantum computers, useful quantum computers. Well, first of all, what term do you prefer to use, and how far out do you think that is? Is it 2 years, the same 2 years out that we used to say 5 and 7 years ago, or does it feel like it's closer than 2 years, or is it still a fair amount more than 2 years away? And how would you maybe technically define it so it's not this abstract hype meme?
When I speak with customers, I ask them, where are you in your quantum journey? Where are you today? Where would you like to be, say, in 18 months from now? And what's stopping you? Why are you not there already? Is it money? Is it technology? Is it the right partner? Is it something else? So when people think about buying a quantum computer, the question is, why do they want to do that? I mean, we both know that quantum computers today, some would say, are useless. I mean, they're almost useless in the sense that there's almost nothing that you can do on a quantum computer that you could not do on a classical computer. However, governments and other institutions understand that quantum utility, as it's sometimes called, is just a few years away, and they better get prepared in terms of algorithms and integration with HPC centers and workforce development, and so on and so on. So we're definitely not looking at the moment at mass production of a quantum computer that is in the current state. But we do see a demand, and we do see that demand increasing year by year. Maybe 3 years ago, no one would At least no one at QuEra would say, oh, people want to buy a quantum computer. They would all say, oh, they just want to use them on the cloud. It turns out that they actually do want to buy quantum computers for a variety of reasons. It could be because they want to run jobs that they don't want to run on the cloud, so sort of security. It could be because they want to use that as a seed for economic or workforce development in country or in the region. It could be because they value control, meaning I want to know I'm starting to have important jobs. I want to be able to make sure that I can prioritize them relative to what others are doing. So there are all these reasons why people actually are buying quantum computers. But we're not yet standing a production line that would pop out 100 quantum computers a week. I think we're still years away from that.
Okay. And that also raises the question about size in terms of size of the organization. Now, if you're going to buy a quantum computer, that's a big cost. But if you're just going to use it casually online in the cloud, anybody could do that, right? You don't even need 2 cents. But if you wanted to do, again, a production application where it's going to be running 24/7, what do you see as the total available market? What's the low end of the market? What's the smallest organization size you could be when we get to production scale that would probably be able to afford to use a quantum computer for a solution? I mean, what kind of IT budget would they be needing to talk about before you would say, look, guys, you can't afford this?
You could make the case that if you ask how much it costs, that means it's not for you right now in quantum, right? But I think that more seriously, you should follow the progression of the GPUs and the supercomputers based on GPUs. And that will give you a good sense of what quantum will be able to do. So look at organizations that own a supercomputer today. Well, why are they doing it? How many are those? How much did they cost? By the way, how much power do they consume, which is, of course, a very big advantage of quantum computers. And then sort of follow the same path for quantum computers. Similarly, one thing that has happened with the AI explosion is that all of a sudden there were not enough GPUs on the cloud to do everything that companies want to do. And there was sort of a shortage of resources. So some organizations might say, as soon as I think a quantum computer is going to be able to do something useful, I want to make sure I have that capacity in-house and I don't have to rely on standing in line with everyone else. Now, quantum computers today take a while to be built, whether it's a year or 18 months or something like that. It's not, next day shipping for quantum computers anytime soon. So that also plays into the forward planning of organizations that try to extrapolate when will quantum computers be useful, how much of a quantum computer do I need, and when do I need to buy one to make sure that I can get it in time to satisfy my requirements.
Okay. Chris, I have to ask a question about hype. So in your view currently, is hype a big deal, a big problem, or is hype itself being overhyped? And what is some of the kinds of hype that annoys you the most? Or what is some of the kind of hype that maybe does the most damage? Or what do you find most laughable about hype?
I mean, I'm in the hype business, right? I run marketing for a quantum computer company. But I think that is sort of tapered down. It's no longer quantum computers will be able to solve every problem tomorrow morning. I think people have gotten tired of that, and of course, it didn't play out this way. Certain hype is required. It's required to help get investors. It's required to attract talent to work in companies. Otherwise, it's boring, right? I mean, why? It's very attractive to come and say, come change the world with us, as opposed to we're just building a better mousetrap. Which type of hype do I find most annoying? Probably competitor hype, right? But I think we're sort of right-sizing the hype these days.
Okay, right-sizing the hype. That sounds like a great takeaway. It was just mentioned marketing. Is marketing and you're heavily involved in marketing is your main thing. Is marketing for quantum any different in principle than any other tech marketing? Are there special challenges for quantum marketing?
I don't think so. I mean, you're speaking to a very intelligent audience. You have to understand where they are in their journey. You have to decide which segments are you targeting. Are you looking at people who need an education on what a quantum computer is? Are you looking at people who run HPC centers and try to figure out where quantum fits in that? Are you looking at physicists that are looking to simulate something else? Obviously, quantum marketing has a significant technical component. It's not exactly like marketing a new beer, but that's what makes it fun. You have to explain business value like you have to do in any other B2B marketing. You have to relate and understand where your customers are and where they want to be. You sort of practice empathy. In this case, what does it mean for you? How does it make you feel? So I don't think that it's any different than marketing, virtual reality products way back then when I was running a virtual reality company or something else.
Okay, great. Getting down to my last few questions here. I hope I can sneak a few in here. On that marketing angle again, terminology. Do you consider quantum computing to be a full industry, a field, a sector, or what? Or should it simply be considered part of HPC, high performance computing? Is that maybe where it's going to end up? Or again, is it a whole industry or just a sector?
We look at quantum computing as a new type of compute, but it's not reinventing the computing industry. Again, just like we went from a CPU to a GPU, and now you could do other things. And the GPU worked in a completely different way, and you had to program it differently, and you had to rethink about how to structure programs that would make the GPU effective. Then there's probably a little bit bigger jump from GPUs to QPUs, but ultimately it's one more way to do computation. We used to say you're never going to run Zoom on a quantum computer. You're never going to run Microsoft Word on a quantum computer. At least I hope not. So it's never going to be the end-all, be-all of compute. But used correctly, it can do things that you cannot do with other type of processors. So it becomes part of a larger compute industry and initially part of a high-performance compute industry.
Okay. What's the biggest customer objection you run into? I mean, is it money? Is it time, resources? Is it all too new? What's the biggest challenge for you when you're trying to have a conversation with a new customer?
I think it's setting expectations correctly. I mean, if quantum is 10 years away, then let's talk in 8 years, right? On the other hand, can you solve my huge traveling salesperson problem today? So there's always some expectation matching to do between them. Obviously, some people ask why neutral atoms or why QuEra, and I think we've got that answer, Pat, right? Very scalable technology, no cryogenic cooling required, more efficient algorithms, natural perfect qubits, no manufacturing defects in the qubits, and so on and so on. People sometimes ask why QuEra, and I think we can make a compelling case why we're both the scientific and commercial leader in neutral atoms. So it's really finding the customer at the right time in terms of what they think quantum computers will do for them and whether they're interested in engaging at this time or in the next couple of months with us. And otherwise, let's be friends and talk again in a year.
Okay. Maybe as my last technical question here, do you have a rehearsed elevator pitch on what is, like if someone says, there are two separate questions. They say, first, why do I need to worry about quantum computers at all now? And the second question is, well, what is a quantum computer anyway? Do you have a simple, like I said, a 30-second, 2-minute, 30-second, whatever kind of spiel for this?
I guess it changes from time to time, but quantum computers are a new type of computers that are powered by the principles of quantum physics. And quantum computers, once they're sufficiently advanced, will be able to solve problems that cannot be solved today in any reasonable amount of time with classical computers. We see quantum computers as having substantial potential in several areas, including optimization, such as optimizing traffic patterns, simulation, such as generating or discovering new materials for better EV batteries or solar cells or vaccines, and machine learning. And between simulation, optimization, and machine learning, we believe that there's huge potential for companies to make to get a very substantial competitive advantage by correctly using quantum computers. And we're here to help you in that journey.
Okay. And now I guess I'm into your standard questions at the end of your podcast. So the first one is kind of, well, what keeps you up at night? I guess we've talked a little bit about that, but maybe your final answer on what keeps you up at night, or how well do you sleep?
I sleep well. What keeps me up at night is that I want to make sure that we can get our amazing technology to customers as quickly as possible. And it's not easy. I mean, sometimes we joke that if building quantum computers were easy, we'd have marketing do it, right? So developing them and building them, making sure the software is there, figuring out the way to deliver and support them to customers wherever the customers are is a challenging project. Not many companies in the world can do that. QuEra is one of the companies that can. But if there was only a way to do it even faster, that's what I keep thinking about.
Okay. And the next question on that is, what's the biggest thing you've learned in the past year or last few months or whatever that kind of was most surprising?
I think the biggest thing that I learned over the past 12 months is the level of interest in the HPC community, and with some HPC centers, and on the other hand, that some are still thinking about quantum computers as being 10 years away. And so we're trying to change that. I remember giving a pitch at an HPC event not too long ago, and they were talking about how their classical supercomputers can do machine learning and weather forecasting and material simulation. And we put up a slide and said, look, we are doing weather forecasting with Moody's, and we're doing demand prediction with this, and we're doing with NERSC and others. We're doing material simulation. And here's our paper on machine learning, on how we prove that there are data sets where quantum computers can outperform classical computers. There are some data sets that exist where quantum is better. And we finished it by saying, look, there's a small set of problems, and this was a supercomputer conference. There's a small set of problems, really small right now, but growing, that our little 256 quantum computer can outperform all your supercomputers combined. And to me, that gap between where we know what we know that quantum computers can do and where HPC centers are was sort of a big aha moment in the last several months.
And you mentioned some of that AI stuff in there. I was just curious whether, since you have a lot of physicists, right, at QuEra? And so how did they react to this Nobel Prize announcement when it was basically all about AI? And, did they react negatively at all, like some of us, where it's, well, that's AI, but it's not physics? Or did they cheer it immensely, or how did they react?
Well, we can't give a Nobel Prize to quantum computing every year, only some years, right? So I think some were amused, some were curious to learn more. I know you've been investigating that, but it's certainly an event every year when the Nobel Prizes are awarded. There's a lot of interest on what's going on, and do I know this person, and have I met him, and has he been a professor in one of my courses, and so on and so on.
Okay. Now I was gonna come to your dinner question, but I was gonna add a variant in there. So before dinner, breakfast. So if you could start your week off on Monday morning with a breakfast meeting with one or more of the quantum and business greats to review your agenda and plan for the week, and to really get like really deeply hardcore into quantum. Um, who might you want to have breakfast with as advisors on a Monday morning to get you started for the week?
When you were asking about hype yesterday, I thought you were going into the hypothetical. Um, I'm an amateur violinist. And when I was very young, just starting out, in grade school, I thought maybe one day I could be the best violinist out of the physicist and the best physicist out of the violinist. And then, of course, I learned that Einstein was a very good violin player. So that went out the window very quickly, very early. So I think that Einstein, of course, would be my first choice for many reasons, including that. I've asked that question by now, maybe 200 guests on my podcast, and I think 100 of them say Feynman. So I'm sure they're right. Would love to meet Feynman as well, but so many others.
Okay. Well, I meant for the breakfast side, but so you have the same answer for the dinner question then, kind of quantum greats dead or alive for dinner. Is it the same for breakfast or dinner? Does it not matter? Maybe.
Yeah, we should have a breakfast or a dinner buffet so I can meet all of them at once. But yes.
Okay. Although the way I phrased the question originally about business quantum greats or business greats is the quantum sector getting to the stage where it needs a fair amount more business acumen to build on the physics, or do we still at the stage where the primary skill we need are the physicists?
Well, I don't want to talk myself out of a job, right? So about 2 years ago, when I was looking for my next thing to do in quantum, I reached out to QuEra and said, look, I look at your website. I look at the people that are on the website. You look like you have a lot of very, very smart PhDs, maybe a lot of physicists. Maybe it's time you have a business person as well. And that got me in the door, even without a PhD. So yes, I think that building systems is great, but selling them, marketing them, taking care of the customer is also critically important. Without that, you can build the best science in your lab, but if you can't get it out to the market, then you only won half the battle.
Okay, and I just have to squeeze in one last little technical question, and I raised this with you at one point about again, is the central focus need to be the research physicist now, or does it need to be more of the professional electrical engineers, the computer engineers who understand computer architecture in that sense? So do we need more physicists still, or do we need more research before we start trying to make it into commercial products? Or where do you feel we are?
Well, we do have commercial products and they're very good, but I think there are many, many physics problems that are not yet fully decided. And of course, many engineering problems that stem out of that. The Apollo 11 onboard computer, I think, had 70 kilobytes of program memory, and it allowed Apollo to get to the moon and back safely. And it wasn't written in HTML, right? It was written in a very, very optimized way to make maximum use of the resources. I think we're at the same spot in quantum, where to deliver true business value, one needs sort of full stack optimization, working from the application level all the way to the hardware level. Oh, you want logical qubits? What are we going to do? Which algorithm are we going to use? How do we encode it? What are the trade-offs? How do we implement that in the machine? I think we're at these early stages, but like the Apollo 11, I do think we can get to the quantum moon and back safely.
Okay, and I probably have 2 hours more of questions, but I think we've gone way over our time, so I think that's it for me on questions. Do you have any last words?
No, it was a pleasure, and it was interesting to be on the other side of the microphone, and we'll get to the next hour of questions in a few months, maybe.
Okay. Okay. So great. That's good. So thanks for sharing your thoughts with us today, Yuval.
Thank you very much.
Talk to you soon.
Everyone.